All right, I know I told you I was going to demo the virtual machine thing today, but I think that's going to have to wait for Friday, hopefully. We actually, if you look at your Wi-Fi, if you're local here, you should see that there's a Wi-Fi thing called CWCS. Uh, Mark Newhouse is going to switch that so that it is coming through the campus Wi-Fi. It'll probably still be called the same thing, but I want to make sure when I show you how to do it, it's the way you'll actually do it, not the way you did it the other day. So he's hoping to get that up today. He thought he might have it done in time for class, but I just want to make sure I show it to you the right way so you don't have issues. Doesn't impact you if you were planning on installing Ubuntu yourself or on your own virtual machine or something like that. All right, so let me. This is 450, right? Is that really not a recent class? All right, let's see what we got last time. Okay, so we were kind of in the middle of talking about our kind of history of our operating system / distribution stuff. And I think I mentioned something along the lines of if you were a consumer Windows user and you have Windows 98, and this is back when they used to sell software on the shelves at Best Buy. You would go in and buy your software. Actually, once upon a time, you bought software at Sears. I think I bought Windows 95 at Sears. And now did all the Sears close? It's not even a store anymore. But
I still buy my software at Sears.
That's like the what's the Chuck Norris thing? Chuck Norris does all his grocery shopping at Home Depot. Something like that. That might have been from the Hitler Chuck Norris thing that Dr. Locklear showed at one of the get-togethers. I think it was when you were maybe a freshman. Do you remember it? Oh man, that was like the greatest Chuck Norris thing. It's like a scene from some movie where he's complaining that the Americans have sent Chuck Norris after him. He swims the Atlantic as we speak. You know, we should use a nuclear device. We based it off of his barbecue. that type of stuff. All right, so in any case, if you were a Windows 95 user, the upgrade to that was Windows 98. But if you were a Windows 98 user, notice over here on the business side, they were all called Windows NT. So Windows NT 3.5.1, this guy actually introduced multitasking because Windows 3.1 did not have multitasking. You could run one application at a time. DOS didn't have multitasking. So Windows NT 3.5 actually introduced multitasking. Windows NT 4 was the new technology kernel that Microsoft actually created using the Windows 95 GUI. So Windows 95, even today, well, actually, they've maybe started slightly moving away from it now, but really that whole idea of the start menu came from Windows 95, and that's stuck through today, right? You know, this is probably the first version of Windows that Windows 10 is probably the first one that it didn't just say start. It's got the little Microsoft-y thing down there and you click it and then, I don't know. I don't think it's as good personally. I think there's like too much going on there. I'd rather have it just give me the stack and go and find what I want. But regardless, I mean, you get used to it, right? But, you know, Windows NT 4 was the business stability with the NT kernel using the Windows 95 friendly front end. Windows 98 was a consumer operating system. Windows 2000, this is where they got into trouble. Windows 2000, which was a great business operating system based on the NT kernel, but it looks like it's the upgrade to Windows 98, right? If you're a consumer, you're in Best Buy and you see the sign that says Windows 2000, you think, oh, I need to get the latest, greatest update for my computer. You buy Windows 2000, you take it home, you install it, And what happens? All of your peripherals stop working. Your joysticks, your scanners, things that were kind of commonplace for consumer-based PCs. I mean, really, you could think about it just from like a graphics card driver perspective. We could just use that one example. All of those drivers, when you write a software driver, and so when I say driver, what is a driver? Maybe you've seen me in the past. I sometimes name my the program that has main in it, I name it driver. Why is that? Let's start off with that idea. Why do I call it the way? Well, it's not just I call it that. What are drivers? If you had to define this, what do you think they are? I mean, we've all heard the phrase, right? Like, oh, you just install the drivers. But what does that mean? What does it mean to install the drivers? What do you think? What's a driver?
Isn't it like the thing that commands all the other aspects? So it's kind of like the, for lack of a better term, like control center.
Control. I'm not sure you actually said anything in that sentence.
So like
Sarah agrees with me. So, okay, go ahead. I think you know what you're talking about, but I don't think you've said it yet.
it's like the main interface that will then, it controls all the other hardware pieces. So it'll say like this should do that, and it knows like when to call on each other piece, and it's like the control center for the rest of everything else. So in our program, when we use it as the main area to call all of our other documents and things like that.
Okay, let's say ish. I think you're in the right ballpark. So let's write it this way: drivers in general, these are pieces of software written to make a specific piece of hardware work. Now, let me give an example. I might move my example to another page if this gets too long, but a really good example is graphics cards. In the early days of personal computers, our expectation of graphics cards was make stuff show up on monitor, right? That was the limit of what we expected, you know. And a lot of times it wasn't even black and white. I mean, you had these old these monitors. Have you ever seen the ones up with the orange text? They have some really dangerous gas inside of it. I don't make those anymore. I think there were some situations where somebody dropped, I forgot the name of the gas in the CRT, but it was yeah, it was bad for you. whatever it was not good for you. But anyways, our expectations of those graphics cards was just make stuff show up on the screen. Okay, so if you've heard of these are just called VGA. Actually, let's call it VGA compatible GPUs. So when I say something is have we all heard of VGA before? We've at least seen those things. So a VGA compatible GPU would be something that is the bare bones minimum requirements for making something show up on the screen. Okay, so no matter what GPU you get, even today's GPUs, you go out and buy the latest, greatest NVIDIA, RTX 3090 GPU, it is a VGA compatible GPU with then a whole bunch of other features on top of that you only get if you have the special software driver. Windows comes with, well, if we roll back to like the Windows 3.1 days, Windows 3.1 would have come with a very generic VGA compatible video driver. Excuse me. And only once you started having these hardware manufacturers start coming out, so if I go back to the previous slide, where am I at here? This guy. So in the early Windows 3.1 days, people were just starting to use their computers for games and stuff like that. But you didn't have this large array of peripherals for your computers like we have today. Once you got into Windows 95, it became pretty common for there to be joysticks and things like that. Not really different graphics cards yet, but definitely sound cards were a big deal. And then, that just kept evolving. But the idea is that our operating systems come with a set of kind of common drivers that allow the most generic hardware to work. All right. So when you first, you put your latest, greatest graphics card you spend $1,000 on into a modern day computer, even at the baseline, it'll boot up, it'll do your memory count, it'll show you all that stuff, and it boots into Windows. And you just spent $1,000 for something that's probably running at like 640 by 480 resolution. It's running in generic VGA mode, is what it's running at. Okay, this is the best I can do, Windows is saying, to talk to this alien piece of hardware that is effectively a rocket ship, but I only know how to tell it to show stuff on the screen. Okay, because it has to be backwards compatible with VGA. So with that in mind, the software vendors would release a piece of software called a driver. And this is a piece of software that you install on an operating system, and it teaches the operating system about the rest of the things that piece of hardware can do over and beyond the basics. Okay? So piece of software written to make a specific piece of hardware work. Example, VGA compatible GPUs require a driver to make them function for anything beyond the generic VGA features. Okay, so that's an example of kind of what drivers are. Now, our operating systems today, I mean, how many of you, it's not actually common anymore because it's just expected now. But if you heard the phrase plug and play, I never heard that phrase before it came out with computers. Possible it existed, but well, I mean, the word certainly existed, but I'm not sure it was a common phrase. But Windows 95 brought this idea of plug and play, where you plugged in a piece of hardware and Windows already had kind of this relatively large collection of software drivers that would make most things work. Because you imagine in those early days, most hardware, I mean, first of all, there wasn't this huge collection of hardware like we have today. But there was an ever-growing collection, but a lot of it was kind of the same kind of stuff, or they would use the same kind of, like for instance, Creative Labs used to have their Sound Blasters sound card. And they had 5 or 6 different sound blasters, ranging from the budget pleaser sound blaster to the, one that runs, 8-point audio or something like that. But I think they were all running off either the same driver or the same suite of drivers. So what happened is Microsoft brought that driver into the operating system. So it was distributed with the operating system. So there was a pretty good chance that if you bought a new piece of hardware relatively early on in the cycle of the new operating system, it would probably just work. Or at least it would have a lot of its features turned on. And then if it was something really game-changing, you would have to install some additional software to augment the features it already had. But the whole idea was you should be able to plug in a USB mouse that had maybe multiple buttons or something like that. And as long as it was kind of in the realm of a normal mouse, it would just work. And only if you needed to have 15 controllable buttons would you have to do something special over and above that. All right, so that's the concept of a driver. All right, makes some sense? So I think what Noah was kind of getting at is it's, the reason I call my main program, the program that has main in it with when I'm dealing with Java or whatever, the reason I call that the driver is it drives the program. So when I start my program, I want my program to run. It's driving the program starting at the beginning of main until main ends and deviating from there. That's why I kind of call it a driver, but it's used in kind of a metaphorical way relative to things that drive hardware, but it's kind of the same idea. All right, makes sense? Okay, so Now we got to think about, well, how are drivers accomplished? And you kind of have to roll back. Let's kind of finish this story a little bit. So if you were running Windows 98 and you walked into Best Buy and you picked up Windows 2000 thinking it was the upgrade, and you brought it home and you installed it, you would realize that all of your things, or a lot of your consumer hardware, didn't work. Because the stuff that was plug and play in Windows 98, that was embedded inside of Windows 98, for making graphics cards and sound cards and all these things function, they don't exist in Windows 2000. Windows 2000 is a business operating system. Its focus was on stability. Now, what percent, we'll use Dr. Locklear's slide, what percent of software has bugs in it? Yeah, 100%, 99.999, whatever. The more software you have on a computer, the more likely you are to have a bug, right? So, and since drivers are software that are running on there, it would follow, and especially since Microsoft doesn't control a lot of them, right? You probably had Creative Labs sending Microsoft the driver to embed into the operating system, and they would release software patches and stuff like that to, to have the, any bugs like that updated. But keep in mind, back then, software packages weren't delivered instantaneously like they are today. You would have to, sometimes they were delivered on like a DVD. You would like buy Windows again, with like, version 2 or something like that. It was like a season release type thing. The internet wasn't where it is today. Okay. So in any case, you install Windows 2000, all your stuff breaks. Graphics card's not showing up right anymore. Sound doesn't work. So your video games don't launch right because they're trying to display higher resolution stuff through a graphics card that doesn't know how to talk to. All because Windows 2000, their business, their server side of operating system, it was stripped down to only focus on stability, which means the less extraneous software it includes, the better. Make some sense? And we'll kind of talk about a way to get around that a little bit today, that modern day operating systems use by having the driver system exist as modules. But in any case, you can certainly see somebody's frustration if they went out and thought they were getting an update for their consumer operating system and ended up coming home with something that made their entire computing world stop working. Right? So it was a kind of a naming snafu by Microsoft, since they named it Windows 2000. Frankly, Windows 2000 was among the most popular business operating systems. In fact, you maybe can still find places running it today. I know up to several years ago, 3, 4, 5 years ago, there was some Windows 2000 machine that had been on for like 14 or 15 straight years, something like that, like something ridiculous. Like it really was considered a very strong operating system, just with an inconvenient name. All right. So that caused a lot of headaches, because keep in mind, last time we mentioned that it's the actual kernel that's the core operating system. Windows 2000 is the distribution of the Windows NT, the updated Windows NT kernel with the business stuff in it. Windows 98 is the distribution of the 9X kernel, which was based off of DOS. Okay, well then Microsoft came out with Windows Millennium. I think it was Windows Millennium. How many of you have never heard of Windows ME? Maybe most of you, right? Yeah, that was kind of the death knell. I remember when that came out, and Dell had a program to allow people to upgrade from Windows ME back to Windows 98. It was a free upgrade program, because you would buy your Dell computer with, it came with the latest thing, right? Windows Millennium on it. And yeah, the world was broken. It tried to be extra consumery, and all the drivers didn't work. It was bad. So after Windows 2000, we had Windows XP. Now, most of us have heard of Windows XP, right? So really, I'm going to write this in a separate category here. Oh, I actually already did it here. It was merged. So when Windows Millennium killed off the consumer version and Windows 2000 was considered a really good, stable operating system, but consumers really can't conveniently use it, the next full release of Windows was Windows XP, which was based on the NT kernel. So now you have the business side stability with the consumer side driver support. Windows Vista also ran on the NT kernel. Any of you ever use Windows Vista? We've heard of Windows Vista? What do we know about Windows Vista? There were some fun commercials with that guy. Frankly, it was actually probably a pretty good operating system from a technology perspective. But anybody know what the biggest issue was with Windows Vista? This was probably pretty close to when Microsoft was at the height of its powers. And also, since the internet was also pretty commonplace then, it was probably the height of the hacker attacking consumers. So people writing viruses and things like that, that people would download through email attachments and stuff like that. It seems like those are maybe, not that they're not founded today, but they're kind of less common, it seems like, because now the hackers have kind of gone pro mode and now they're attacking, elections and countries and banks and stuff like that. I don't care about grandma's Windows machine anymore. Not that it doesn't still exist, but I think it's, they've evolved into the next level of hacker. But during this period of time, I mean, the idea of your machine getting infected was a major concern for a lot of people. And obviously, if you're a hacker, you're a virus writer, you're probably not the most ethical person in the world, right? Okay, so if you're a jerk who likes to write viruses, you want to affect the most number of people possible. So if that's the case, do you go after the Windows community, the Mac community, or the Linux community?
Windows community.
Yeah, you go after the 99% of the people running Windows. Back maybe it was 97. I think now it's probably still 95. I mean, Windows will never lose their dominance in PC computing, right? What'll end up happening is mobile computing will make desktop computing go away. And I'm not just talking about laptops. I think right now the real war is going to be something between, maybe iOS, not so much Android. Android really hasn't made a push towards their tablet OS as being more like a computer, kind of like the iPad professional type thing. Kind of seems like, hey, you can do most of the things you could do on a laptop, you can do it on an iPad. As computer scientists, we don't really view it that way because we're fairly limited from that perspective. But from the average consumer, we're starting to get towards that. I think Microsoft, they kind of missed their opportunity with the mobile, right? They didn't get onto the bandwagon with Android versus iOS. They were late to that game and missed that. But I think now with their Surface Books and the idea of having kind of Windows and Windows 10 in both tablet and laptop mode or whatever. I'm not sure it's quite there yet, but I think that's the legitimate competitor to like the iPad Pro right now. So I think what you will see happen is you'll see things move towards a RISC based processors and moving away from Intel more towards the RISC processors. You just saw Apple come out with their the newest laptops running their M1 chips, which is a similar architecture to what their actually it's the same architecture as what the iPad runs on and the iPhone runs on. So one of the things that they're going to be releasing is you'll be able to run iPad apps natively on the M1 MacBook Pros because it's running the same. In fact, as of right now, you're running macOS and you're running all your previous software on the new MacBook Pro. It's the smaller MacBook Pro. It's the 13-inch MacBook Pro M1. But technically, those pieces of software are not running natively on that computer. They're being translated in real time by a virtual machine that's turning it from M1 based processor instructions into Intel based processor instructions, which is, well, the other way around. Intel based processor instructions into M1 processor instructions, which is actually installed in the computer. So things are going to feel a little bit slow, although all the reports indicate that it's done pretty well. But that's certainly not going to be you don't want that to be the permanent state, right? You know, you want the permanent state to be that software gets rewritten and is now native for the M1 processors. And maybe it takes a company like Apple to kind of push that envelope, to kind of force that. So they gave that transition, and this has happened in the past. It is related to what we're talking about here, but in the past, so you had on the Mac side, we're talking about operating systems. Oh, I'm hitting the up button. I thought it was the down button. Mac OSs. Let's call that the right way of writing it, I guess. Apple was really boring. So what was the first OS to run on Apple computers? And where did they get it from? Microsoft. So Microsoft had to deal with Apple computers as well. In fact, you can you can probably find it on YouTube. So originally it was DOS that was running on all the Apple computers. Now inside of Apple, there was two teams. There was the Apple team, and then there was the Macintosh team. So you had these two competing teams inside of Apple, with the Macintosh being kind of the idea moving towards the graphic user interface type of applications. See, back in the early days of computing, everybody was, maybe going to get into the bandwagon. Last time we talked about IBM being a company that's like, hey, we want to get into the personal computer space, but we don't write software. Microsoft came in and said, hey, we want to license you the operating system we don't actually have, but we'll go find one. Since we have the deal, but we want to license that to you. Well, they did the same thing to Apple. But at the time, Apple was probably kind of like the cool kid, because they had like their own they were more in the hobbyist market, where they had these home built computers that they they had a strong following from like the super geeks and things like that. Where Microsoft was always more towards like the normal consumer, not the person in their garage with a soldering iron, where that was kind of the Wozniak, Steve Wozniak from Apple. That was his role with Apple. Steve Jobs was kind of the muse, something like that, where Wozniak was kind of the brains. Not that Steve Jobs was stupid, but he brought a different skill set to the table. Frankly, Apple wouldn't have been what it was without Steve Jobs' passion, right? Crazy or not, just he had that level of passion that it takes that to maybe change the world. So, and I'm guessing the story about Patel I probably told in a different class, but we'll segue into it anyways. But regardless, so they originally ran DOS on their machines, but then Steve Jobs was introduced to. Any of you heard of a company called Xerox? Who's Xerox? Copy machine place. Okay. And Xerox was working on a personal computer because, like I said, back then, everybody and their brother wanted to, at least find out what these PC thing was all about. And they had a computer that they had codenamed Xerox Star, which used a mouse. Mice didn't exist before that. So they had a thing with a GUI. And then Xerox decided to discontinue the program and decided, you know what, the real money's in copy machines. They've done all right. Yeah. They've done all right. But the real money is in copy machines, so we're not gonna pursue this project anymore. But hey, we're buddies with these other cool kids down the street, Apple, and Apple came in and they gave them, all the engineers gave them, kind of gave away the farm for the operating system for the Xerox Star, and that's where the Mac OS kind of came from. Now, what's interesting is the day that Steve Jobs was introducing the Macintosh Lisa. So the first, it was like an all-in-one Mac running a graphic user interface. Simultaneous to that, computers were shipping in China running Microsoft Windows, which looked a lot like, so then it becomes like this weird, whose fault? So Xerox begrudgingly, according to their engineers, begrudgingly gave their OS to Apple, who released it as the Mac OS, while Microsoft seemingly stole those ideas to release Windows on top of DOS and shipping it on machines to compete with their own partner, Apple. And the video's up. You can see Steve Jobs gets word of this while he's on stage announcing that machine, and you can see his expression change. It's kind of an interesting historical moment. So obviously that was when the Microsoft, Apple hate each other world started, right? But then then they got back and were friends later, because obviously Microsoft became wildly successful, and Apple had a couple of stumbling blocks. So, and like I said, but some of the people in this class might be from some, maybe haven't had me before, or haven't had a class where I've talked about this before. So we'll just complete the loop here. But the finished history of this whole architecture thing, which I think takes us back to this M1 processor thing, is Steve Jobs, once the Mac was kind of becoming more popular, you still had a competition between the two of them. He went and hired the what was the CEO of Coca-Cola? Was it Pepsi? Pepsi, to come in and run the company, so that he could focus on the Macintosh side of things. Well, then the guy ends up turning around and having the board fire Steve Jobs. So Steve Jobs gets fired from his own company, because it's a publicly traded company. He goes out and gets a company called Pixar. If you've heard of that. So he made some money off of that. But while Steve Jobs was gone from Apple, he founded a computer company called Next Computers, that was trying to, maybe it was kind of a Unix-based thing. It was trying to bridge the gap between, back then, again, you had the war between Apple and Microsoft. So it was trying to bridge the gap between those two and try to support both sides. And it was really kind of targeted towards the education world. And it got installed in several universities, but it was pretty expensive and things like that. Well, Apple started failing as a company when they started moving away from being proprietary. So it's a kind of a funny thing, if you think about the folks in this class, I'll just take a rough guess and say about half of you probably at least accept Apple, and half of you hate Apple. And part of that rationale, the love-hate relationship, comes down to the difference between open source and proprietary. A lot of us hear that word proprietary and it's almost like a four-letter word, right? We hear it as a negative, correct? But it actually is Apple's special sauce. The proprietary nature of Apple is their special sauce. And back then, I mean, you could get IBM compatible computers, because IBM became the, they were the cool kid of hardware back then, and Microsoft was the cool kid of software back then. And together they, had whatever, but Microsoft was licensing their software, so they weren't married to IBM. So now you had a whole bunch of other companies coming out with IBM compatible computers, what we would call a PC, personal computer today, that was, had the same hardware in it. That same thing's true today, right? You go to Best Buy and you look at 10 different computers, they all got the same crap inside of them, right? They all running Intel processors, they all have some, Samsung RAM or, whatever it is. So it's the same stuff, just with somebody else's logo on the outside of it and their pre-installed bloatware software that you do the best you can to get it all uninstalled the second you get the thing home. But the punchline here is so Apple decided, oh well, we want to. People were complaining. And I say people, the non-Apple enthusiasts were complaining. If you've been drinking Apple's Kool-Aid, you don't complain about anything. I think if you've had me in the programming language classes before, we talk about the history of the languages. Swift was not an answer to the Objective-C programmers. If you were an Objective-C developer writing stuff for Apple and writing stuff for iPhone, you loved Objective-C. It made you feel just weird enough and just elite enough that you thought you were better than the other people. And it's true. To this day, I like Objective-C better than Swift by a lot. I mean, the Swift lost me with the emojis. I've been on that rant before. But in any case, Apple with Swift was appealing to the other folks, the Android developers, things like that. That's why it looks similar to Java. All right. But internally, Apple was hearing from the world that, oh, we want to run Macs, but we don't want to pay Apple prices. Apple has a monopoly on their stuff. And so people, consumers, viewed that as a negative, right? And Microsoft was so popular at the time that Apple wasn't a good alternative for the masses to go to. If you were a gamer or you were running normal business software, unless you were in an Apple-centric ecosystem, the software that your company ran wouldn't run on the Mac. You know, and if you were at an Apple-centric place, the software that you were running didn't run on the PC, but who cares? That's only 5% of the rest of the world. And I'm probably being generous by saying 5%. You know, so at the end of the day, Apple made this push towards becoming less proprietary, only to realize that it almost caused them to fail as a company. So then they acquired, and their failing days, it was kind of a weird business deal, but they acquired Next Computers, installed Steve Jobs as the CEO, the interim CEO, because they didn't rehire him. He came with the acquisition of Next Computers. So Steve Jobs founded Next Computers. Apple acquired Next Computers, I'm guessing for no money. Must have been some sort of business deal because Apple didn't have any money. Steve Jobs was making their payroll after he came back. So he came back, you know, then he had the iPod, the iPad, the iPhone, blah, 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 the iMac. There was an iBook. You seen the iBook before? It's an Apple laptop. Oh, the iBook was cool. I'm actually surprised these didn't stick around. This was during the same period of time as the original iMacs that had all the different fruit colors were out. Yeah, look at this guy. Look, $500. You can have one today. Lime green. And it had a little handle on the back. Yeah, those things were cool. But related to what we're talking about here, notice it was running a G3 processor. That's a PowerPC RISC-based processor, not an Intel processor. So for a long time, even though Apple got its footing back as a legitimate computing company again, it was still running processors that were, here's the original, actually doesn't, I think Dr. Wall has one of these in his office. We had one, yeah, and I thought he didn't want to see it die. Oh, there's the handle. See the handle? Yeah, those things were awesome. So you had this compatibility issue, and this is kind of where we start moving back towards us in here. All right, so one of the things I've mentioned, I probably mentioned it last class, is a lot of times you hear the same stories, but we're talking about them from different angles. Okay, so ultimately what we had now is you had Apple back as a viable company with a new operating system. Let's go back to our slides here. So Mac OSs, they had DOS, then they had Mac OS, let's just do 6.9. So Mac OS 6, Mac OS 7, Mac OS 8, Mac OS 9. You had a couple of iterations in between, like, 8.4 or something like that. Kind of interesting that, Apple typically, they usually have crazy names for their stuff. Not necessarily, that interesting, but, all their other operating systems that have come out since have had names of stuff. They ran out of cats, right? So after Mac OS 6 came out, they came out with Mac OS X. Now, or after Mac OS 9, it came out with Mac OS X. Now, the question is, was the X, did it stand for 10, the sequel to 9? Or did it stand for the X in Unix? Because really, Mac OS X was the next OS with an Apple-designed front end called Aqua. So basically, it was a Unix-based operating system from Next Computers that had a new windowing environment that effectively looks like what my Mac has on it today, pretty close to it. Okay, but it was still a Unix-based system. So this is a Unix-based OS compiled for the PowerPC RISC architecture. What do I mean by that? When I say that an OS is compiled for a certain architecture, what am I talking about? What does that mean? That's pretty important to what we do in here in this class. Did we look at Hello World Assembly last class again? I know you've seen it with me before, but let's see it through some new eyes now. Hello World Linux Assembly. I always use the same example. All right, remember this guy? All right, so this is some assembly program. So programming, so this is low-level code. So this would be the output of a compiler. So let's just assume this is a Hello World program. So let's say that somebody wrote Hello World in C. Let's call it the C programming language. They ran it through the GCC compiler. Ultimately, which is the compiler we'll be using in here, ultimately it produced this assembly code. All right. Now, what we're looking at here is there's two pieces to this. This was, if we're assuming it came from a C program, I think that's a fair enough assumption for this. This was a C program that got compiled into Intel-based architecture for the Linux operating system. So there's two pieces of information that are important when we talk about compiling. I thought I had a slide that talked about that, didn't I? Is that in an earlier slide? I kind of vaguely remember that just from the other day. Let's just write it again. Compiling. So when we talk about what a compiler does, a compiler translates from a high-level language into a low-level language. Where a high-level language has a one-to-many relationship with the CPU, low-level language has a one-to-one relationship with the CPU, where the CPU is like that collection of magic tricks where, I did the whole finger wiggling thing, how many of you can do this, how many of you can do this. None of those things are all that impressive in and of themselves, but you put those moves together, you can grab a cup and do things. So CPUs are kind of the same thing, where they have all sorts of little tiny things they know how to do. And none of them are all that interesting in and of themselves. But when you call upon them in bulk and in a certain order, things get accomplished. Okay? So that's what a low-level language is. And that low-level language has a one-to-one relationship with those magic tricks on the CPU. Okay? So a compiler requires two pieces of information to successfully compile high-level code. What architecture are we targeting? And what will this drive? This will drive what is the assembly language output. So what's the syntax that's allowed for our output? That has to be the syntax that's understood by that processor. Intel-based assembly looks different than PowerPC-based assembly. That G3 processor we saw a few minutes ago on that one Mac, and then there was a G4 processor. These are IBM PowerPC processors, and they had a different instruction set than Intel does. So they were running what are called RISC processors, reduced instruction set processors. So they actually had presumably less magic tricks. They tried to accomplish the general problem-solving ability of a CPU, general purpose CPU, using less magic tricks to accomplish it, with the idea that less magic tricks means smaller processors, means less heat. So as long as we can accomplish the equivalent final result less heat and more power efficient is better, right? Well, they lost that war for a period of time because obviously Intel became pretty popular for things that were plugged into the wall. So what did we really say? You know, as you know, most American companies, I'm sure it probably was driven by this. Who cares about the bill? As long as it's fast and we're running off the power, we'll use what works, right? So we care more about the output than the cost of getting the output. Reduced instruction set processors had benefits, but at the cost of performance, they weren't as fast for that period of time for many tasks. There was some special sauce the G4 processor had. It had this technology built into it called AltiVec that I think was kind of a precursor to what Intel calls hyper-threading today. Pretty similar thing to that, but you know, Apple kind of had it first. But regardless of that, ultimately Apple jumped ship on PowerPC processors and went over to Intel. So if you have a Mac today, chances are you're running an Intel processor. But if you have a Mac a year from now, chances are you won't be. It's going back the other direction. So again, let's finish the slide. So we require two pieces of information. What architecture are we targeting? That's the output assembly language we're going to have. And then what OS are we targeting? We want to utilize the power tools. Well, actually, let's call them the system calls of the target OS to reduce the size of our compiled output. What that means is whoever wrote that operating system already wrote, for example, they wrote, and let's kind of go back to this guy here. We have it 2 or 210? 2, okay. Well, I'll compress this and we'll have a good starting point. So this code here, let's presume it was C code that was compiled targeting the Intel architecture, probably the i386 architecture, because there's some supersets of that, but let's just call it that, the Intel architecture, and the Linux operating system. And you're going to see in here that the reality is that even though this looks pretty verbose for a Hello World program, it's actually significantly shorter than it should be. And the reason for that is because it's taking advantage of things that were already written into the Linux operating system. One of the things Linux knows how to do is to display stuff on the screen. Okay, it does that through a system call called syswrite. Okay, so the way this assembly works is you say, this is what I want to do. I want to call system call number 4 from Linux. And that guy is syswrite. Syswrite requires 3 inputs. Where am I writing it? What am I writing? And how long is it for the endpoint of the pointer? If you remember how when in the 300 class, when you did C++, you have where pointers end. You know, you might have a string and you allocate some memory and bucket 0 is here. And the length of the size of, for instance, let's say an array of int, size of int times the number of buckets is the last legal position of it. So you need to know how long it is so it knows when to stop reading from memory the stuff it's writing out. Okay, so the syswrite system call requires where am I writing it, what am I writing, and how long is it? 3 function calls. This is when we interrupt and ask the kernel, so call the operating system, to come in and take over. What does the operating system do? It immediately looks in this, it's called the hardware register. It's part of the operating system, or part of the Intel CPU. So it's going to look in this bucket and find out, this is what you want me to do. Okay, so I now know I need to look in these 3 other places to find out where am I writing it, what am I writing, how long it is, and then this presumably complex program that was already written and already compiled gets called as a secondary power tool for us to actually do the writing of the message to the screen. Presumably it's hundreds and hundreds of lines of assembly code that's embedded in this system call that's already part of the operating system. So that when we compile our program, we don't duplicate all the logic that's in here inside of this program. We just call upon that external piece. Make sense? Lastly, for the sysexit, we say, here's our system call for sysexit, which Linux expects the magic trick number 1 for sysexit, and it doesn't require any inputs. This is the result error code for it. Interrupts, calls the operating system, that's our kernel. It looks up and says, what do you want me to do? Okay, I'll kill off the program. Here's my error code. Everything works successfully. We're all done. So again, when we're compiling, we need to know the architecture and we need to know the OS we're targeting, and those two things work together. All right, questions, comments, concerns, bribes?
It looks like that kind of reads like bottom to top. Is that accurate to say?
What, this?
Yeah.
No, it reads top. I mean, this is just like their variables. So this is the data center. So this is like where you would define your variables. So I think maybe that's what you're saying. It's the bottom to top. So variables are kind of defined down here in this data section. These are labels within the assembly code. So they're defined down here, and then they're actually used up here in our start code. But it's these things label where the stuff is. I would say most modern assemblers would probably not care if you put them in different order, but that might not necessarily be true. I usually use NASM, N-A-S-M, which we'll look at in Linux, and I think it's modernly probably pretty flexible when it comes to things, as long as you have your labels in the right place.
Okay.
All right, so I will see everybody on Friday. We'll finish up this conversation, and then we will get our first homework assignment.
Yay.
What's up? Okay.